extra practice in graphing rational functions, I've just listed 2 examples, 5 and 6. So we'll take a look at 5. I see I can factor the denominator. I can quickly see that I don't have an x minus 2 or x plus 2 in the numerator, so both these restricted values will be vertical asymptotes. Okay, I'm going to put my graph here and all my information here. So x cannot be 2, nor can x be negative 2. And number 2 said, let's look at what each of these are, and they are both vertical asymptotes. Okay, so our domain, I guess I didn't save myself some room, but our domain would be all real numbers except for negative 2 and positive 2. We're really kind of interested in the vertical asymptotes because they help us sketch, so I'll just go ahead and put those tick marks on here. So the 2 vertical asymptotes divide the graph into 3 sections. Okay, let's look for the horizontal asymptotes. Okay, so n is 1 and m is 2, so bigger on bottom. So n less than m, bigger on bottom, means that we have a horizontal asymptote at y equals 0. So that's actually just the x-axis. Let's find the x and y-intercepts. So that's x equals 0. That was easy. So 0, 0. So our x-intercept is the origin. So we'll go ahead and plot that. And that's it. That's the only x-intercept we have. And then the y-intercept. It's f of 0. I've got 0 over 0 squared minus 4. 0 over anything is just 0. So that should also be the y-intercept. So the y-intercept is also the origin. All right, based on what we have, let's see if we can kind of sketch the graph, or maybe we'll need to plot additional points. So coming back up to the graph here, over here to the far left, either my graph's coming on and then bending upward, okay, or my graph's coming on the screen and bending downward. And I really don't know which one it is. So how about if we take, this is negative 2, how about if we take negative 3 and see if we get a positive or a negative answer to tell us where we're located? So I guess I'm going to put that up here, f of negative 3. Negative 3 on top, negative 3 squared minus 4. And really all I care about is, do I have a positive y or a negative y? So I've got negative 3 over 9 minus 4, or 5. So when x is negative 3, I have a negative y value, so I'm down here. So my graph must be coming on and then bending downward to avoid the x-axis. Okay, I'm going to go ahead and tackle this branch to the right of the furthest right vertical asymptote. I'm going to actually plug in positive 3 now, because I want to see, does my graph come down and leave the screen this way, or does my graph come up from down this, from negative infinity and leave the screen this way? So really all I care about is at x equals 3, do I have a positive or a negative answer? So let's put positive 3 in, so 3 over 3 squared minus 4. So that's going to be 3 over 5, so that's positive. So my graph is actually up here, so it must be coming down this way, and then as it gets further out on the x-axis, it's going to start approaching y equals 0 that way. All right, now in between I've got a graph, so the same thing. I'm going to plug in negative 1 and positive 1, and all I care about is when I plug in negative 1, do I get a y value that's positive or negative? And I think I've already done that. When you plug in a negative, I think you get a positive answer. You do. So the graph's coming down this way. So when it hits this X and Y-intercept, does it bounce back up or does it continue downward? So now let's plug in 1, and when we plug in 1, we're actually going to get a negative answer. So that tells me the graph has to continue down this way, kind of bending and approaching kind of negative infinity down this way. All right, let's look at 6. I do notice that I can factor out an x from both terms in the denominator. And I think we saw this graph in our previous work. So when we're done graphing it, we should be able to check with one of the graphs that we saw previous. I'm pretty sure that was the equation. All right, notice that x and x will divide out, so that tells us that the restricted x value of 0 is a whole. Let me get the grid going. So this is going to be your domain here. So we know the restricted x values are x can't be 0 and x can't be 4. So negative infinity to 0 and 4. So we know at x equals 0 and x equals 4, x minus 4 gives us the restricted x value of x equals 4, but there's not a common factor, so that's a vertical asymptote, but x equals 0 is a whole. Well, this is going to be an interesting one. So I'm going to go ahead and put the vertical asymptote on at 4. So notice I have two sections of my graph, the part of the graph that's to the left of x equals 4 and the part of the graph that's to the right of x equals 4. But we also have a hole at 0, so wherever that graph is, as we kind of draw it in, we'll have to go back and take out that point. All right, let's look at 3. N is 1 and M is 2. So N is less than M, bigger on bottom. So that means y equals 0 is our horizontal asymptote. I'm going to put that up here. So kind of dash that in, but better yet, I think I'll just kind of highlight y equals 0. Okay. And then X and Y-intercepts. So x equals 0, we're done. So 0, 0. So that means the origin is 0, 0. Or the x-intercept. So I'll go ahead and put that on there. So I do have a point there. Actually, we don't, because x equals 0 is our restricted x value. And if it's saying that x equals 0 gives us our x-intercept, that can't be. That means that this is where the hole is. The hole is actually occurring at the origin. Because if this equation gave us x equals 0, then that tells us that x equals 0 back up here is a restricted x value. So this is where our hole is right here. Okay, let's find the y-intercept. It's probably going to be the same thing, but there's going to be a hole there. So what happens is we get f of 0 equals 0 over 0 squared minus 4 times 0. And this one's interesting because notice that we get 0 over 0. That's what we call indeterminate. Well, we can determine what this is. When you have a 0 in both the numerator and denominator, that's an indeterminate situation. But remember, we also saw that x equals 0 was a whole. So we kind of have to connect back here and go, okay, so there's not a y value because of that hole that's occurring at x equals 0. All right, so what do? Well, the graph's coming on the screen this way. It's got to come into the hole, leave the hole, and then either approach upward or downward. This is a lot of point plotting. So I would plug in maybe something like, if this is x equals 0, I would plug in maybe -1 to kind of see what's happening over here to the left of this hole. So f of -1. So -1 squared minus 4 times -1. So I have -1 on top. This is 1 plus 4 or 5. So at -1, I'm down here at -1/5. So that's telling me the graph's coming onto the screen this way, maybe kind of bumps down a little bit, picks this point up, and then has to come back up here into the hole. Now from here to here, let's plug in 1 and see where that point leads us. So f of 1 is 1 over 1 squared minus 4 times 1. So that's 1 over -3. So that's negative, which is kind of weird because when you're at x equals 1, you're down here at -1/3. So it must be leaving this hole and then probably is going to, I can't come back up because I have no more x-intercepts, get closer to this vertical asymptote and head downward. This was kind of complicated. To the right of x equals 4 is my branch up here going out this way or coming from underneath down here from -infinity and leaving the screen this way. Well, remember this is x equals 4, so let's plug in x equals 5. I don't have a lot of room, so I guess I'll put it right here. So, and all I care about, do I have a positive or a negative y value? So let's plug in 5 to the original equation. So that's positive 5. 5 squared minus 4 times 5. So I've got 5 over 25 minus 20. 25 minus 28 is 5. 5 divided by 5 is 1. So I'm up here. So that tells me the graph's coming from up there and then moving outward towards y values of 0. That one just made it a little, this one was just a little bit more complicated because that hole and all the investigation we had to do on either side, the left and the right of the hole, by doing some more point plotting. But hopefully all the other stuff kind of came together for you on these examples and were helpful.